Dear students, greetings from Dr. T. Senthilmurugan, Associate Professor, Department of IT. In this video lecture, we are going to discuss about multicasting, what is multicasting, basics of the multicasting, and intra-domain multicasting protocols, inter-domain multicasting. These all the topics under third unit. Dear students, in this video lecture, this is week 10. Week 10, lecture 2 and lecture 3, we will cover in this video lecture. So this is classroom discussion topic 29 and classroom discussion topic 30. It will cover both intra-domain multicasting and inter-domain multicasting. Okay. So this is the lecture outcome. End of this video lecture, student will be able to use multicast routing protocol. So now you know what is multicast routing protocol. Then after ending this lecture, you may use this protocol for your real-time applications and classify the intra-domain and inter-domain routing protocols. So if any protocol is there, then you can easily classify it, okay, according to the performance and usage. Okay. So what is multicasting? Multicasting means we know that one to many, that is group communication. Normally we discussed in previous lectures, one to many communications. Okay. So like one source, but destination is many. So the source will send a message to all the destination at a time. Okay. So we can say the relationship is one to many. So in this type of communication, source address is the unicast address. Source address is unicast address, but destination address is group address. Okay. So this group have separate address. So this source have separate address. This is source. Source have unicast address. The group have multicast address. Okay. So you just remember it. So what condition we have to follow? Any one of the member should be a group of this, should be member of the particular group. Okay, just remember. So if in many destinations, any one of the destinations should be a member of the group. That is the multicasting conditions. So what is group address? Group address defines the members of the group. Okay. So we know that multicast address, how it will be worked. You see this diagram. This diagram represents the multicasting, how it is working. Okay. So this is the source network, source router. So this network is the source network. This is sending the message. Okay. So source a node, unicast address. The node, this node will sending the information to this router. Router will read the packet. Accordingly, it will forward where it wants to. So see here, in this router, two nodes are connected, but these two are not a member. Okay. So here, in this network, at least one member is there. Okay. So one member is there. You assume that. Like that, you just assume there is no member. There is only one member. Here, at least one member is there. So that means these members are in the particular group. This is one group. This is one group. Like that, you consider. So when the source is sending the unicast address through this is the unicast address because the one system is sending to the router. Router will identify if any members are there where it wants to send. It is a multicasting means it will check where the members are there. So it will forward it to the multicast router. So already you just see here the multicast router represented using gray color. This X mark is there. So this is represent that multicast router. It is not unicast router. Unicast router will be blue color is there for representation. I am saying. Okay. So you consider this a multicast router. These dotted lines are saying that point to point connections. Okay. So point to point connection means it directly connected to the particular network. Okay. Wide area network. So see that the flow of the blue color lines, it will send that message to the router 1. This is the router 1. How 4 ports are there. First port, second port, third port, fourth port. It is receiving the message from fourth port and it want to forward to where. So it will check this route 1, there is no member, so no need to forward this link. So here one member is there, then this router is forwarded to next router. Okay. So here this router will decide where it will send. So in this group, one member is there, then it will forward. In this group, no member is there, that's why it is not forwarding here. So here this router 4, we have two network. Those two network also have the members in that network for that group. Okay. So you just imagine with your WhatsApp group. You may be in one group, your friends may be in some other group. If your friends is in that group, you also get the message. If you are sending message to your friend, that message will goes to that particular group. So normally we are saying no, you forward your message to your friends group. We are saying no, same like that. That is multicast. Okay, you are sending message to your friend, but your friends may be in some other group. That group, he only one person is member of our group. So he will get the message and he will forward to that entire group. Okay. So we must be know that what is multicasting, what is multiple unique casting. Okay. So multicasting and multiple unique casting. What is that? That means multicasting means the message will be single message that will be delivered. The same message copy will be delivered to the group members. Okay. There is no individual message. Message is common, that the common message will be taking the copy and it will send it to individual group of the members. But here you see this is multiple unique casting. Here you see multicasting using multicast router. Okay, the gray color they are using, but here they are using unicast router. So why multiple mails are there? For example, multiple information is there. The message have reached to multiple destinations. It is not into the group, individual message, that unicast. Same message, multiple copies are there. The individual copy will reach to the destination. That is multiple unique casting. Okay. So now you just think about it. What is multicast addresses? How it will be delivered? Okay. So you just think about unicast address and multicast address. So in multicast addresses, why we are using multicast addresses? You think about it. Okay. So in unicast packet, the destination. If in case if unicasting, what will happen? The unique when we send the unicast packet to the destination, the source address of the packet defines the sender. The destination is represent the receiver. Okay. So clearly we know this, who is sender, who is receiver. This is a unique casting. Okay. So but in multicasting, what happened? Sender is only one. Okay, only one sender. But it may be reached to multiple destinations or any number of members all over the world in different groups. It may reach. Okay. So if multiple persons are there, no, how we can include multiple addresses in the address bar? So that is very difficult. Simply we are informing to the internet protocol that this is multicasting protocol. So how we can represent that? So there is some addresses will be there. So multicast address is represent that group of recipients, not a single one. Okay, the address itself is showing that it will send to many people. So see this presentation, what happened? Multicast address, how it is working. In IPv4, we know that 32-bit addresses. Okay, 32 bits addresses. In this 32 bits, we have the classifications A, B, C, D, E. Okay. So in out of these 5 classful address, we know that class D is specially designed for multicast addresses. What is the range of these addresses? 224 to 239. How we are saying this 224 to 239 is multicasting? So already we know that the binary values out of 32 bits, the first 4 bit will decide it is the multicasting or not. The first 4 bit is 0001. So see the diagram. If the first 4 bit is 0001, the remaining address will be represent the group identifier 28 bits. So then it is considered as the multicasting address. So how we can say this, the IPv4, how we can represent it normally? So if IPv4 address, 4 bytes we are representing using dotted notations. Okay. So the first byte will decide that which type of address. So the first byte 8 bits are there. So these 8 bits, first 4 bits are already defined. These 4 bytes are defined for multicasting. The remaining 4 bits are defining the unicasting. If you are given all 4 0, there is a first address, which is that 224. Okay, fine. Remaining all are 0. So that's the first address. So this is the first address. So if in case the first 4 bit is defined and last 4 bit is 1, this is the last address. So what is the value of these 8 bits? That is 239. Okay. So 239. The remaining all are 1 means the remaining values are 255, 255, 255. Okay. So that only they are given here. So this is the initial addresses, starting address and ending address. Okay. So this figure shows the black and binary values. So you just see here. So we are using only 4 bit for representing the entire multicasting addresses. That's why they are using slash notation 4. Okay. So these multicasting addresses have different multicast addresses are there. So really in our computer network we have 5 types of multicast addressing is there. First one is local network control block. So this is one of type of the multicasting addresses. How we can say that if any address from this sub block 224.000.0.0/24, it is showing that it is the local network control block. Okay. It is used for the inside the network. What is the meaning of that? Means the packet with the destination address is in the range, cannot be forwarded to by a router. Okay, so directly it will deliver the information to local network. So out of this network, some IDs are there, no initial IDs. So 0 ID is for reserved, 1 for send the datagram to all the hosts as well as routers. Okay, both host plus routers, that is 1. Okay, so in case 2, what is the meaning of that? Send the datagram to all the routers inside the network. Okay, not all the hosts, only routers it will send. So like that, rest of the addresses are assigned to some multicast protocol communications. So next, first one is local network, second one is inter-network. For inter-network, it must be use this block for multicasting. 224.0.1.0 compared with previous one, here 1 is came. So what is the slash notation? 24 bit it will take. So wherever we are using this address, this is considered as the inter-network control block. So what it will do? It will do the whole internet, which means the entire world we can do it. Then another block is source specific multicasting block. So in that block address using 232.0.0.0/8 notations. These 8 bits will decide the number of addresses in the SSM block. In glab block, what is glab? So don't ask any expansion or abbreviations. Okay, acronym or abbreviation. It is simply we are using the internet. So it is used for sending the information to autonomous systems. Okay. So already we know some 3 types of autonomous systems: sub-autonomous system, multi-homed autonomous system, and transient autonomous system. So if we want to forward the multicast address, means it is nearly these many addresses will be there. Okay, how they will take that X and Y value? It is the autonomous addresses. That 16-bit number will represent the autonomous system. That X dot Y. So remaining 0 to 255 will be used as the autonomous system. So administratively scoped block. So this is administrative purpose. There is separate block is there. That block is 239.0.0.0/8. that 8 bit will be decided the number of addresses for administrative support. So now network with multicast support, how it is working? So network means the network layer will send the data to MAC layer, that is data link layer. Okay, the network layer providing the services to data link layer. So data link layer, it is used to physical address or MAC address. Okay, physical or MAC address. But in network layer, they are using logical or IP address. Okay, so we know that IPv4 have 32 bits. So these 32 bits, we know that IP address. Here we know that MAC address having 48 bits. So how we can map with these two addresses? So in that, we just consider first 25 bit will represent the Ethernet address, like MAC address. Okay. So remaining 23 bit is there. So out of 48, so 25 bit will represent for Ethernet address. So remaining is 23. So these 23 bit will represent the group of the multicasting. Okay. So how we can convert this address into MAC addresses? So if we have IP address, if we have multicast address, from using these two, how we can generate the MAC address like physical address? So that we will discuss in this slide. So you just see here, this 4 bit will represent the multicasting. This 5 bit is unused. The remaining 23 bits will taking for the multicast address. Okay, so these last, so in MAC address, what happened? MAC address have 48 bit totally. So out of 48 bit, 23 bit will represent the multicasting address. Remaining 25 bits. These 25 bits are same to all the multicasting addresses. Okay, how it will be there? See there. So this is the multicasting Ethernet address. Okay, so these addresses ranges is considered the multicasting in MAC addresses. So in case if we have IP address, okay, so this is the IP address you will consider. So then you have to identify the MAC address for multicasting. How you can identify? So first initially, first 3 bytes. So it's the MAC address have 6 bytes to represent the address with acted values. Okay, so here if 6 bytes are there, no, first 3 bytes will take Ethernet address. First 3 byte is common to Ethernet address. You see here in the top, these 3 bytes are common to all. So these 3 bytes is represent that it is the multicasting addresses. So that 3 is common to all MAC addresses. The remaining 3 bytes will converted to IPv4. IPv4 last 23 bits. Okay, so IPv4 last 23 bits. These 25 bits will be from this physical address directly. So how we can calculate it? So example, this is the IP address. How we can write the binary value for this? So 7, example, last byte 0000111. This is 7. Okay. The next 14. 14 means 8 plus 4, 12 plus 2. 14, 0, here all zeros. This is 14. Okay. Then this is 43. How you can write the 43? Again, 32 plus 8. 32. 16 is 0. 8, 40. Then 43 means 8, 4 is 0, 1, 1. This is 3, 43. So here, these are the bits. 4 plus 4. Okay. So this is 43. So we have to convert into hexadecimal value. Again, how we can convert 4 bits? 4 bit is represent 7. This 4 bit represents 0, 7. So the hexadecimal is 0, 7. Here, what is the value? 14. 14 means E. Okay. So these 4 bits 0. So what is the value? 0 E. Okay. So here 4 bits. So what is the value? 8 plus 3, 11. 11 means B. Okay. So here what is the value? Only 2. Okay. So what is the address? 2B, OE and 07. So this is identified from the IP addresses. Okay. So in case it will be how? So the last byte is there, no? Here. What we are written in the IP address? 43 is there. So instead of that, 2B is there, no? 2B we have. So this value is more than 8. Okay. If 2 is there, less than 8 means no problem. Same thing we have to give. In case, if it is more than 8 means, you will minus 8 with this value. Okay, that you have to do while you are converting. And there is two type of multicasting is there. Source based tree approach and group based tree approach. So because source based tree approach means each router needs to create a separate tree for each source group combinations. So that means if in case m groups are there, in n sources are there, means so totally m cross n root tree should be created from the corresponding source. So in this tree, corresponding source is the root of the tree, and remaining members of the groups are leaves. Okay. The members of the groups are leaves. Then who is the source? That will be considered as the root. Then router itself is somewhere on the tree. Okay. This is source based tree approach. Group shared tree approach. This is also one of the multicasting technique. What is the group shared tree approach? So here we designate router as act as a pony source of the each group. So that means designated router. So we will give one router as a designation. What designation? That is the core router or రెండవ spine router. Okay. So if these routers are considered as representative for the group. So what is the use of representative? Representative means he is the leader. If once he is received the message, he will forward it to all the members. At the same time, if any source wants to send the message, it will send to the core. Then core will forward it to all others. This is group shared tree approach. So in this group, what happened? There is m core routers will be there, and each core router have the routing tree. Okay. So total for the total of m trees. Okay. So that means that number of routing tree is reduced from m cross n. So which is available in the source routing to m. So here directly m router with m tree. There is m router and n sources m into n tree. So this is better part compared with the source based. Okay. So now we are going to discuss about intra-domain routing protocol. Already we know that distance vector routing protocol and inter-domain routing protocols. Distance vector routing protocol and link state routing protocols are there. Okay, these two types, that is how it will be used for multicasting. Multicast distance vector, how it is using. So it is used for source-based tree approach. So this distance vector is used for source-based tree approach. So that means each router in this protocol that receives the multicast packet, okay, to be forwarded implicitly create a source-based multicast tree. How it will be forwarded? Initially, we have three methods. The router uses an algorithm called reverse path forwarding. Okay, so reverse path forwarding RPF. It means simulate creating part of the optimal source-based tree based on the source and itself. Okay. So sometimes router uses an algorithm called reverse path broadcasting. So RPB. This is for another type. So the third method is reverse path multicasting. So these three methods used for forwarding the packets to the multicast routers in multicast distance vector routing. Okay. So further explanation you read from the textbooks. The next one, link state routing. The link state routing, one of the routing protocol is open shortest path first. Already we have discussed in the Unicast routing protocol. So same protocol may be used for multicasting purpose also. So that is considered as MSYF. It is extension of OSPF protocol only. OSPF used for unicasting. So MSYF is used for multicasting. How it is working? It is used again source-based tree approach only for multicasting purposes. But how it is working? If internet is running in the unicast link state routing algorithm, the idea can be extended to provide the multicast link state routing algorithm. So how it will be work? Link state database we know. Based on the database, the router will forward the datagrams. So how they are extending unicast to multicasting? The unicasting protocol OSPF. So this protocol, how they are extended? Each router needs to have on another database. What is the database? In the case of unicast disinfectant, to show the interface of the active members of the group. So that all other nodes database is needed to forward the information to multicastings. Okay. Clear. So now we are going to discuss about the multicast link state route. In this route, how it is working for multicasting concept. Now a router goes through the following steps for forward the multicast packet received from the source S and sent to the destination G. How it is doing? First, initially, the router uses digital algorithm to create shortest path with S as the root and all destination in the internet as leaves. Okay. So what happened? Digital algorithm already we have discussed, finding the shortest path. So this route, this route, this route, like that, it will identify the shortest route for the particular group which is connected to particular source. The router finds itself in the shortest path tree created in the first step. So first step what it will do, source will find the shortest path for all the destination using the digital algorithm. Okay. So these shortest path subtree is there, no? That is actually broadcast subtree. Okay. So the router as the root node to all the network. Okay. If the router to all the nodes means it is broadcasting. The router can now forward the received packet out of only those interfaces that correspond to the branches of the multicast. Okay, so if we are forming that tree, like this is one way, this is another destination. So we know that this is another destination, like that we are identified individual tree, no? So these particular tree will receive corresponding branches. That is the method used in the multicast routing. You see here, these are some tree formation of MOSPF is there. This is the internet, some active groups are there. The groups are represented with the G values, G1, G2, G3 are group names, and these are the routers used for unicasting. Okay. Initially, you see this is the source. Source will, this is the current router. Okay. So this is the source node. Yes. Yes, G1 shortest path. So from this node, it will identify the shortest path. So finally, how it will be do? It will start from the S, this node. So what is the shortest node? This is one direction, this is another direction. It will connect it. From 2, it's a minimum value. Then it will start from the G2, this router. In this router, which is minimum, this is the minimum compared with the 5. Okay, so it will comes here. So after reaching here, it will identify this is 5, this is 2. So then the link will be established here. So once it is reached there, then here out of comparison, this is 4, this is 1. So the link will be connected here. Finally, the link will be connected here. Okay. This is SG1 shortest path. So then SG1 subtree seen by the current router. From the current router, what it will do? This is the current router means the from this remaining router it will send the information source to destination. Okay. Yeah. So now we are going to discuss about intra-domain routing protocol. Okay, so intra-domain we are already discussed. Now we are going to discuss about inter-domain routing protocol. So in the same inter-domain we are discussing the unicast routing is border gateway protocol. Here also we are used multicast border gateway protocol (MBGP). Okay, so this is used for in inter-domain routing protocol. So how it will work? There is two paths between the autonomous system. MB multicast border gateway protocol provides two paths between the autonomous system. One for unicasting and one for multicasting. Okay. The information about multicasting is exchanged between the border routers in different autonomous systems. Okay, so the autonomous systems will be there in the different places. So border gateway maybe is there, these routers. So these routers will use this information about multicasting. The border gateway protocol is shared group multicasting routing protocol. So it is used for each autonomous system to choose Rendezvous point. Okay, so already we have discussed what is Rendezvous point. So accordingly, it will forward the information. Okay. So now the problem with MGP protocol, what is the problem? So it is difficult to inform to the RP about the source of the group of other autonomous systems. So for that, what it will do? Multicast Source Discovery Protocol, MSDP. That is the new protocol. It is used for assigning source representative router for each autonomous system. So what it will do? Each autonomous system, one representative it will assign. The representative is the responsible to send the information to all the members. Okay. So that another one is gateway multicast protocol. Okay. So this border gateway protocol already we know that. So this protocol allows construction to share the group trees and single route to one of the autonomous system. Okay. So finally, the protocol that is used today for multicasting is Internet Group Message Protocol. So IGMP we are using for sending the information for group members. Okay. So what it will decide? It is used in the network layer. It is one of the auxiliary protocol. Okay. So like ICMP, what it will do? If any error message is there, it will inform to the source. But same like that, IGMP also will work. So what it will do in IGMP, there is different messages are there. Two type of messages are there in the IGMP. One is query message, another one is the report message. Query message means it will ask when we are sending the datagram, the packets are going correctly, delivered to the correct members or that. Okay. Response message means it is delivered properly, acknowledgement message. If it is not received, some complaint. Query message is forward direction, report message is reverse direction. Okay. So there are some how the query messages work. The general query message means it's sent about membership in any group. Okay. The group specific query message. So general query message is there that is sent about membership. This group specific query message means it's sent from the router to ask about the membership related to the specific group. And source and group specific query message means it's sent from the router to ask about the membership related to the specific group when the message comes from the specific sources. Okay, so these type messages are there. Okay. So now we are in the end of the session. So I just read this statement, which is it is related to which topic. Okay. So it will take 10 seconds time. You have the options. So from these options, you can identify which is the answer. It is source-based tree approach or group shared tree approach, IGMP or ICMP. It will take 10 seconds time. If you are chosen the correct answer is group shared tree message. In group only, they are choosing the core center. From the core center, it will deliver the message to all the members in the group. So it is group shared tree approach. If you are choosing the correct answer, you proceed. Okay. So otherwise, you read once again you watch the video. So first we have discussed about the multicasting addresses, how it will be used. So how we can change that. The multicast addresses ranges from 224 to 239 in IPv4. So the first 4 bit will represent 1110 is represent the multicast addresses that we have discussed. Network with multicast support, that network layer will communicate the MAC layer. So we are convert the 48 bit MAC layer address from the IP address and multicast address. Okay. So that we have discussed. Two approaches for multicasting. One is source based, another one is group based. Okay. Source based and group based that we have discussed. And multicast distance vector routing protocol, it is extension of distance vector routing protocol, which is used route information protocol. It will apply the multicasting. And link state routing also we have discussed OSPF, that MOSPF we have discussed, multiple open shortest path first protocols we are discussed under that. IGMP we are discussed at the inter-domain routing protocol. Okay, I hope you are enjoyed this video. So having completed this discussion on multicast routing protocol, this is unicast already we have discussed. Multicast routing protocol, the student should be able to use the multicast routing protocol. Now you know what is multicast routing protocol, how you can use it in the real time. That is also you know, and you are able to develop new multicast routing protocol also. You are develop the new algorithm. So for further readings, you can read our textbook Horizon with data communication networking, chapter 21 for multicasting. And also you can refer the weekly tutorial sheet for better understanding. Thank you very much for listening.